we're going to use the graphing calculator to show you how to answer these questions. We're going to create a scatter plot, discuss correlation, find the sum of least squares, find the equation of least squares, graph the line of best fit. By the way, those are the same thing. And lastly, we'll interpret the data. First thing we got to do is we've got to get this data into our graphing calculator. So we're going to plug that in by hitting Stat, Edit. We've got to clear what's there. So once it's cleared, now we're going to go ahead and enter the data. I'm going to pause it. You don't need to watch me add the data. Once the data is entered, it's always a good idea to go back and look and make sure, one, you have the same amount of data in both lists, and two, that the data is correct. All right, first thing we want to do is we want to find the equation of least squares or best fit so that we can get everything plotted and find the least squares. So we're doing a bunch of this stuff all at once. So here we go. You're going to first hit Stat, Calc, and you can use either number 4 or you can use number 8. Number 8 is the one we're going to use today, so you can just hit 8 or you can hit Enter. And it's asking for a couple of things. Now, some of you have a menu that asks for list 1, list 2. This version doesn't have the menu, so we're just going to say I know that my data is in list 1, comma, list 2 for the y values, comma, and I want them to put the information in a specific place in my y equals. So I'm going to hit vars, V-A-R-S. If I hit that, go over to y vars, function number 1, and I'm going to select number 1. I want to put it right there. Now that I've done that, I can hit enter, and notice a couple of things that it's done. It gives me A and it gives me B, and my B value here is my slope. So slope equals 2.456. My y-intercept, we'll call it B. However, this is actually B, and this is A. Okay, these are what we know of. 3.298. Now I'm going 3 decimal places because I want to be as accurate as I can. If you do less, numbers are going to be off a little bit, but you got the idea. So my equation is y equals 2.456x plus 3.298. Now, one of the things I've done is I've already put it in y equals. So I'm going to hit the y equals button up there. Notice that it's there. Okay, now before I graph that, I want to set up my stat plot. So if I hit second y equals, I can turn on my stat plot on. I can scroll down. I can choose dots instead of lines or bars. Okay, my x list is in 1, my y list is in 2. I like the dots because that way I can see the dots over the line that's being graphed. And now, once that's set up, if I hit zoom and I scroll all the way down to zoom stat. Now I could try zoom fit. Zoom stat is a little bit better for statistics. And what you're going to see is you're going to see the data. So I'm going to hit 9. You'll see the data graphed and the line that goes through the plot. Now notice it not only accessed the data in the list, but it also accessed the y equals here. Okay. You can now transfer that onto a piece of graph paper. All right. Now where are we at? We have created a scatter plot. The discussion of the correlation now is that this graph is positive And I'd say it's fairly tight, so I'm going to say it's a strong correlation. Now, we're also going to look at the sum of least squares. That's our next step. We're going to have to go back to stat, edit. We're going to go over here to list 3, and we're going to type in this equation, but in place of x, we're going to refer to list 1. So it goes 2.456, second function 1, plus the y-intercept 3.298. And if I hit enter, it's going to go ahead and calculate all the y values now for my new best fit line. In list 4, I want to find the difference between my data and the y values for my best fit line. So simply, I'm going to go list 2 minus, minus list 3, enter, and it fills it in. Those are my residuals, and you can copy down the residuals all you want. Okay, but the residuals now are going to lead us to the squares. Okay, now I'm going to show you 2 different things when I'm done with this. But the squares, if you go up here, you can go list 4 squared. And notice that the buttons on the right here tell you what buttons I'm pushing, so you can always pause the video and see what buttons I've pushed. If I hit enter, it's going to fill in the squares. Now I need to know what the sum of that is. So that's just simply stat, calc, 1 var stat, 1 variable stat, and we're now in list 5, right? What did I do? List 5, not just 5. There we go. And notice that sum, it says sum of x is equal to 15.1228. That's the sum of the squares. Now I want to do this one more time. Stat, calc, 1 var stat, and let's put in list 4. If you remember, list 4 was the residuals. Okay, and notice there that there's a on that screen there, this value right here is the sum of the squares. So I didn't actually have to create that other column. I could just get it from the sum of the squares of that, and notice that's the same numbers I had before. All right, so am I done? Last thing I have to do is I've got to interpret this data. To interpret this data, it helps to go back to the graph, knowing that we've got the days studied versus the score earned. If I go back to my Desmos graph, or I'm sorry, not my Desmos graph, my graph here, notice that as the number of days go by, the number of days that I studied, the better the test score. And we know that the slope of that was 3.298. Slope equaled 3.298. So for every day I studied, my score seemed to improve a little more than 3 points. All right, and we are, I think, done with that.